to talk about enhancing your API security with Gloo Edge and Web. Let's have a small introduction about the speakers today in this session. It's going to be me. I'm Erez Schiller. I'm a team leader at Web. I have over 10 years of experience in the info security with over 14 years of development. I've been in the IDF and many other companies since joining Web. And I've been a researcher for API security since 2019. Denis?
Yeah, so I'm Denis Jannot. Really happy to be with you guys. I'm taking care of the field engineering team at Solo in EMEA, and working on this cloud native space since a long time and diverse technical roles. And highly involved as well in a lot of topics around API gateway, service mesh, eBPF and so on.
Okay. So we are a full lifecycle solution platform for API security threats. We're composed of cybersecurity leaders and some of the inventors of the API security space. We're about 40 engineers and product team members, mainly in Israel, but also in the US and Italy. We're focused on, as I said, the API security space, and really the changes between API security and traditional security. We're going to talk about that later on, as well as show a demo of the technology and integration between the Web platform and Gloo Edge.
Yeah. So, and on Solo side, we are located in Boston, but we have people all around the world. I have many people in my team in Europe. We are focusing on this application networking layer, let's say, which is composed of API gateway, service mesh. We have a solution around GraphQL and eBPF and so on. So we are really highly involved in the Istio community, in the Envoy community. We have committers there. So today we are going to speak more about the Edge product, but we also have our Gloo Mesh product around service mesh, and we have this Gloo network layer that is embedded CDM as well.
Okay, so let's talk a little bit about API economy trends. We're really seeing extended use of microservices and APIs in organizations. They're rapidly adopting APIs, and really for good reason. I think if you're on this session, I think you know very well all the benefits that come with APIs. They really unlock a lot of value to businesses, to IT teams, mashups of technologies and partnerships, and they allow us to do things we couldn't do before. The issue with that model of security for APIs is that adoption is by far outpacing security. We're going to talk about that also later. And the rapid iterative nature of APIs and endpoint development makes many of our customers change their code multiple times per week and even per day. So testing and security for these kinds of rapid iterative changes is very difficult and very challenging. And also the nature of attackers is different. The core concept I'd like to get across is that modern API-based attacks are mostly logic-based attacks, and we'll give examples later on, but they cannot be defended by traditional rule-based systems like WAFs and API gateways. They're very used to look for specific headers or for SQL injections. So basically these traditional defenses, they can't deal with the logic-based attacks because they really don't have the context that logic-based attacks utilize. We're seeing exponential growth in the use of APIs. According to Akamai, 83% of traffic today is API traffic, and that's a lot different than what we've had maybe even 5 years ago. So we're seeing a huge spike in usage, and it's projected to grow by 30% every year. That's really pretty amazing stats. We're talking about 42 trillion API hits by 2024. And actually, Gartner predicted back in 2017 that APIs would be the number one attack vector in 2022. And obviously, we are now in 2022. And last year, they actually revised that, saying they missed the target margin, but only because they underestimated the growth of APIs and API traffic. So like in everything, there are two sides to this coin, the pros and the cons. Basically, we're getting all these great things like connectivity and integration, API products, marketplaces, everything we see on the left-hand side here. But we're also getting the other side of that coin. And we're seeing that roughly 50% of APIs in our customers and in general are unmanaged. And that creates huge blind spots for security teams. And obviously, fundamentally, to secure APIs, we really have to know about them. And these APIs might expose issues and might not be visible if you only look at traffic. So it's important to really get into the code and close as many of these blind spots as we can. Let's talk about three key things that are important in API security. Number one, the attack surface is different. I mean, the core of the change is we're moving from monoliths to microservices. We're expecting more and more from our APIs than ever before. And for that, we use API gateways like Gloo Edge to enforce policies consistently across our architecture. But these APIs still expose application logic. And as the attack surface changes, so do the attacks. We're seeing that many, if not most, of attacks against APIs today are not traditional injection-based attacks. And some of them, they're not really hacks. If you look at what happened with Cambridge Analytica and Facebook, it's not really a hack. What happened there is that Facebook exposed an API for a mobile app, and a third party, in this case, Cambridge Analytica, realized that they could extract tens of millions of user data with this API. They didn't really crack any encryption key or hack any passwords or apply an SQL injection. They used the logic that was exposed by Facebook in a way that's different from what Facebook intended. So I wouldn't say it's really a hack. So that's what we're seeing. We're seeing attackers realize business logic issues and gaps in APIs and utilize BOLA, mass assignment, and other vulnerabilities, and just exploit these vulnerabilities in authorization in order to get user information or apply unauthorized changes. So therefore, we have to change our defenses as well. WAFs and API gateways, they can't defend against these threats on their own, as these threats are logic-based attacks. So yeah, they're very good at defending against OWASP top 10, but they're not good at defending at OWASP API top 10. We're talking about the WAFs and API gateways. And I could say that it's easy for me to say that these things are important because I'm a team leader in an API security company. But that's why we've brought some references from OWASP, from Google, and from Gartner, talking a little bit about the criticality of discovering your APIs before attackers, why you should use specialty products and firms, and that you should design API security into the full lifecycle. In addition, Gartner just made their reference architecture. They just modified the reference architecture, to include API security as a dedicated layer. That happened just within the last quarter or so. So we're seeing...
Yeah, sorry to interrupt you, Erez. We got a comment that the presentation is really small. And I thought it was only on my screen, but it really looks like it takes a very small... Oh, yeah. Can you do it even bigger? Or?
Unfortunately, that's the biggest.
That's good. That's good. That's already like twice the size. So sorry for interrupting you, but because of this slide, is more like a lot of things on it. I think it's important for people to see it.
Yeah, sure. Thank you. So yeah, you can see that Gartner modified the reference architecture to include API security in there as a dedicated layer, and that happened just within the last quarter or so. So we're seeing things happening and evolving in real time in the space of API security. And if you guys don't have API security programs in your organization, that's fine. Don't feel bad, because roughly 62% of organizations don't. But since it's number one, it's now the number one attack vector. It's a pretty serious issue, and it's time to act. This is the original OWASP Top 10 published in 2003. We'll talk about a little bit about the difference between the OWASP Top 10 and the OWASP API Top 10. I think we're all familiar with this list. I'm not going to read it to you. You have it in front of you. But this is what WAFs and API gateways are designed to defend against. We've been using this list with various small modifications for about the last 20 years. So the key is that these defenses are mostly rule-based defenses designed to handle these kinds of attacks. But now we're seeing mostly logic-based attacks. So there is some overlap with the previous list. This is a list published in 2019. We can see that injection was number 2, and now it's number 8. Most attacks against APIs are not done by injection. It's still something you have to defend against, because these types of attacks do happen. But in general, this new list now reflects the priority of attacks that we're seeing, with number 1 being the most prominent attack, BOLA, which is broken object level authorization. And what does that mean? What does that actually mean? Well, it basically means that there is an API the user is permitted to use on his own resources, but can, due to a lack of authorization, apply the same API to other users' resources, or get other users' information via that API. We've seen examples exploiting this ability to do things like download passports, or change private or access private files, change user photos, really anything that has the resources attached to them. So any action that involves resource level authorization may be vulnerable to these attacks. And the issue is that in most cases, the organization wouldn't be aware that this attack had happened, because their WAF doesn't have the context. It doesn't understand the logic of these APIs and that we're accessing other people's resources. So that could have very harsh consequences on your business. And we're seeing it in the wild. It's impacting a lot of companies. And if you're lucky, and when adoption outpaces security, then issues would be surfaced by a security researcher. Like in the case of Coinbase, they're halted their trading because they found out the issue that they had. But in other less fortunate cases, or when companies are not ahead of this issue, we see that attacks surface by law enforcement, by the media, or in very bad cases by ransom demands. Well, that brings us to our solution. So the way that we're combating all these issues is a holistic approach to API security that starts with traffic analysis and traffic inspection. We first discover your APIs, giving visibility into what APIs you have and how they're used, which expose personal information like bank accounts, emails, etc. And then we build a baseline of your usage and detect anomalies. Identify APIs that could be vulnerable to BOLA, mass assignment, injection, and other attacks. But really, it's not enough to just look at the traffic. That is what first generation API security products did. And there's really nothing wrong with that, because they built the foundation of API security and they started this space. But going forward, they can't give you full visibility of your APIs. To do that, you also have to get into the code. And that's what we've done with code analysis. Code analysis really analyzes and tests your API vulnerabilities before they even get to production. It also lets us cross-reference data and detect old or unused APIs that might not have traffic but still be exposed, as well as give us a full picture of the APIs in the organizations, not just the ones that we see traffic for. We see that especially in large companies with many teams, working on many APIs, there are a lot of unmanaged and unused APIs. These APIs aren't used, so there won't be any traffic for them, but they could still be attacked. And in most cases, these APIs would be less secure as they are considered old or obsolete by the company itself. So having this visibility and closing these blind spots really helps minimize the attack surface. And the third piece of the puzzle is our attack simulator that actually attempts real attacks against your APIs. And we do that for two reasons. To find vulnerabilities that you weren't aware of, obviously. And also, we like to validate our findings and really minimize false positives before we raise these issues with your security team and your development team. We really want to give you the best possible results, and we're using attack simulation to validate results from our other engines to really give you the best results. And as well as let you know when attacks have been remediated, when we've surfaced an issue and you've told your dev teams. So we run that issue once in a while to let you know that the issue has been resolved within your system. And then on top of that, with our compliance office, compliance defender, we provide the lens. You can see that in the bottom, into your compliance obligations as a company. Really line of sight into which APIs are servicing PIIs, PCI, credit card information, etc. And what is amazing is that even in large and well-funded organizations that we did our POVs with, we found really critical and really big visibility gaps. We did one with a big worldwide logistics firm, and we installed our traffic inspection engine. We quickly discovered 30 APIs that were undocumented and unknown. And we saw that one was actually vulnerable. It was a complete blind spot for them in production. And they were running WAFs and API gateways in production, but these WAFs and APIs couldn't see the attack surface that are based on logic-based attacks. So I'm going to pass the mic over to Denis. He's going to talk a little bit about our solution together.
Yeah, thanks, Erez. So also don't hesitate, guys, if you have any questions, you can use the chat to ask us anything, right? Let's try to make it as interactive as possible. So what Erez said is really interesting, right? It's like basically it's complex to protect yourself against all these attacks, right? And what I want to do here is like to put that in perspective about what's going on currently in many organizations, right? Basically today, like a lot of these security mechanisms are implemented directly by the applications, right? And you see the complexity that Erez mentioned about all these vulnerabilities. So today, basically, a lot of companies expect that all the application team will be able to handle all these kind of attacks by themselves, right? But in fact, what happens today is that these teams, they even also have to implement authentication and basic security by themselves, right? So you look at a team that has a front end like a UI they want to expose. If they want to secure access to this UI through like OIDC workflow, then they generally implement that directly in their application, and they do that for one service. Another team do that for another service. Another team do that for another service. If they expose APIs, then they would secure these APIs, with like API keys or JOT tokens and so on, right? And it's really not like the ideal situation because they are not expert in security, right? And they should really focus on the business logic instead of focusing on or spending time implementing all these mechanisms. And there are some other issues, right? Like, for example, if you have a security team that is responsible for, auditing everything, right? They don't know what's, how everything is protected. So they have to talk to each team, one by one, right? And on top of all these things, you also want to implement other mechanisms that are not enough, like Erez said, but that are important still, right? Like, WAF in the web application firewall to protect you against some sort of attacks, rate limiting to avoid people abusing your APIs and so on. And these things you generally handle them in a legacy firewall or API gateway that you cannot really program as code with the modern tools and so on, right? So if you move to the next slide, Erez, I think that I already summarized like most of the points. But like the idea is that all these microservices that we describe, they tend to now be deployed in Kubernetes, right? And this application team, they basically want to they don't want to spend time like writing code to secure their APIs and so on, right? But they still want to be able to control and decide how, what, I don't know, identity provider they use for securing this API or this UI, right? So if you go to the next slide, Erez, so what we've implemented since some time now at Solo is that this API gateway called Gloo Edge, which is based on Envoy and which is Kubernetes native. What does it mean? It means that I can configure all my security and all my routing and everything through YAML, right? Through Kubernetes object. So the application team who wants to authenticate the users, they don't need to implement that in their code anymore, but they can use the YAML to describe how they want the API gateway Gloo Edge to implement this security mechanism. And this API gateway can do more than just authentication, right? It can be used for rate limiting, WAF. You can implement like complex workflow. For example, it's very common that our customers, what they do is that let's say you authenticate a user with like a Jannot token, right? And you want to extract from this Jannot token, you take a claim and create a new header based on it. You can transform this header to, I don't know, extract, let's say the claim is the email claim. I want to extract only the domain name that represents my organization. And then I want to do a rate limit based on my organization. So you see, I have like this complex workflow that I can implement to have like secure rate limiting, right? Nobody can abuse by just sending their own header, right? So you can do all these kind of things. You can obviously do everything as code because everything is configured through Kubernetes object. So it's like, compatible with modern CI/CD pipeline with GitOps tools like Argo or Flux and so on. And you can still even use it to expose services that are not on Kubernetes. Like if you have legacy services on VMs, or if you have Lambda functions, for example, we have a lot of customers who are using our API gateway for that, right? So if you go to the next slide, Erez. So as I said, I mean, the basically this slide is kind of showing you how this solves the problem we discussed before, right? So the ability for the application team to focus on their on the business logic is, instead of like writing these authentication features, the ability for the security team to know what's going on, because now they can just take a look at the configuration of the API gateway to know exactly how each API or each application is secure, right? And I think I already mentioned the rest. So you can go to the next slide, please. And as I said, if you look at the architecture of Gloo Edge, basically this is based on Envoy. And if you're not familiar with Envoy, you have this notion of filter chain, right? So you have like multiple filters, and the request that comes in is basically going through these filters, and each filter can alter the request or reject the request and so on, right? So for example, if I want to authenticate my user with like OIDC workflow or my API call with a OAuth token, right? I can go and talk to this external auth server that implements it. If I want to apply rate limiting, I can do the same. And there are many filters that we implement directly in Envoy itself. So we write our own filters in C++, right? We have like a filter based on mode security for the WAF. We have filters that are there to do like data loss prevention, all these kind of things, right? And here I speak about Gloo Edge, but just wanted to mention as well that obviously in Solo we also are very involved in the Istio project and in service mesh in general, right? And everything I have explained about the fact that the application team, they want to delegate this security to the gateway is true also with the service mesh, where these applications want to delegate the security mechanism in the mesh, right? And because they are both based on Envoy, right? And Istio, for example, has this Istio Ingress gateway, we are able to do exactly the same with this Istio mesh, right? So we are able to transform the Istio Ingress gateway so that it becomes something like Gloo Edge. We don't replace it; we just enhance it so that it becomes the same as Gloo Edge. So basically, what's interesting also, if you just go back just one quickly. So no, on the other one, sorry. No, after. Sorry. So one thing that I want to mention here is now how everything is coming together, right? So the idea of what I presented is that you want the application to focus on business logic and delegate the security to an API gateway, and it's the same for what we provide, right? You cannot expect that the application team will protect themselves, one API at a time, right? You need to have a mechanism in place so that you can have like a security team can know what's going on, and you can take some measures and protect your APIs and so on, right? So if you go again on the slide with Envoy, right, one of the things I didn't mention is that one of the filters that you have in Envoy is this WebAssembly filter that allows someone to load some custom logic. If you're not familiar with WebAssembly, it's a language that has been it's not a language, but it's like a binary format that has been built for the web browser to be able to load some custom logic in the browser that you don't want to write in JavaScript. You want to write in a different language, and you want to load that and interact with JavaScript. And the Envoy community reused this binary format to allow people to write some custom logic in different languages and to compile that into this binary format, so that now you can inject it and you say, I want to inject this WebAssembly plugin, and I want like to, I don't know, intercept the request and modify the headers, or if there is this logic, enrich the request with additional header by talking to another endpoint, or I don't know, modifying the response or rejecting a request in some circumstance. Like, you can do whatever you want. Basically, it's like implement any custom logic that's that makes sense for you, right? And if you go to the next slide, basically this is where we yeah, I think it's not shared anymore, Erez.
Yeah, sorry.
Yeah, no worries.
It's working now?
No, we cannot see the slides anymore. Oh, good, and it's big now. That's perfect. And then like I will let Erez go through that. But what I really want just to highlight here is that basically the way we integrate together is that Weeb has built their own WebAssembly plugin that allows them to shadow the traffic. So in Envoy, you have like a way to shadow all the requests or mirror the request, but you cannot mirror the response, right? And that's the beauty of WebAssembly. You can do whatever you want, and this is exactly what they have implemented in at Weeb. Basically, they are able to get a copy of the request and the response, and get all this data and find some potential attacks from there, right? So Erez, up to you now.
Thank you. Yeah, so just like you said, we've implemented a WebAssembly plugin. It's safe to run. It only mirrors the traffic. It runs in a safe mode, so it can't affect your traffic, and it doesn't affect your performance. It also buffers the traffic apart from the handling of the request and the response, so it's not going to add any latency to your existing requests. And basically, it runs within Gloo Edge, and it mirrors the traffic to our system, to Weeb, so we can analyze it, do all the things we've talked about, build the baseline, and detect anomalies in your environment. So the integration is very simple because it's simply installing a WebAssembly on Gloo, and they've made it very simple. So it's very, very straightforward. This is the technical explanation, but in general, it's very simple. The first step creates an upstream, basically telling the Web plugin where the data is going to go, where is the Web platform located, because we do support on-premises and SaaS deployments as well. So some customers might use an on-premises, and some customers might use the SaaS environment. So we need to know where to send the data to. We also support non-SSL and SSL connections as well. And the second one simply tells Gloo, hey, we want to run Web's WebAssembly as part of the chain. And that's it. It's a very, very simple two-step installation, and Web is a part of your Gloo Edge installment, and we're ready to add the security value to your platform. So let's do a short demo. I'm gonna reset the screen sharing 1 second. Just 1 second, please.
In the meantime, if you guys have questions, don't hesitate to ask in the chat. We'll be happy to take them.
Okay, so we have a pre-made environment here with the Gloo connection. And as you can see, all the APIs that we've called have been discovered, and you can see the discovery of APIs in our system. Basically, we can tell you everything about what host names, and this is automatically discovered. No one loaded any information to the system, any Swagger open APIs. Basically, you can see all your APIs, which ones expose personal information, which ones expose or utilize authorization, and that really gives you a very, very detailed look into your environment. So as you can see, for example, this is an API that changes users, that puts users information. You can see that we've detected fields as personal information. We've detected phone numbers, IBAN numbers in case of bank accounts. So we really tell you guys everything about your APIs and how the request is usually used. For example, this address is basically always a number between 1 and 1,000. So we really learn the usage of your APIs and give you a lot of insight into how your customers are using your APIs and which APIs you have to really make sure to defend, because they do hold personal information, and exposure in those APIs could be really problematic for your organizations, obviously. So yeah, it's a very simple integration, and it really works seamlessly. Sorry. I think that's it for today. Any questions?
Yeah, I didn't see any questions, so I think that's fine. If you have question later or want to try out this, our stuff, right? Obviously, you can try both or just one of them. But you can contact us on Solo side. We have our Slack where you can find us and very easy to interact with us. We also have a lot of workshops and events, so you can just go in our webpage. And Erez, perhaps if you want also to explain how people can reach out to you.
Yeah, sure. They can reach out to us at Solo.
Even better.
Yeah, we had a slide for that all along. So yeah, if you're ready to become API secure and utilize our API security with the Solo and Gloo Edge, please contact us at solo@web.com.
Thanks a lot, Erez, and thanks for people who joined the talk. Hope to hear about you in the near future.